Hello, good evening and Assalamualaikum to the Muslims. So how's everybody? Okay, Jefferson,
Doing fine, doing fine.
okay, Azani, Akshay. Okay, previous classes we talk about descriptive analytics. Descriptive analytics is about the past and current. I mean, you look at the past data. I mean, records, the past records of your business, and then what is the current position, your current position. And then next topic, we move into data mining and text mining, which we look into modeling, and so that from the past record, we can predict what will happen in the future. We can see the trend and so on. Yeah? So then we move on to prescriptive analytics. How do we make decisions? So today we will cover two topics I've uploaded in your LMS. Two topics, which is on the first one is on the topic on model-based decision making. So how we make decision, how do you make decision based on the past records, and then based on the trends, your predictive analytics, your data mining, text mining, and so on. How do you make your decisions? Okay, the first hour I'll cover topic 6. We'll cover two topics today, and then that second hour I'll cover topic 7. Yeah, which is okay. And then we will share my screen. Where is my slide? Okay. How do we? Okay. 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 We'll talk about Wait, this, no, okay, wait, hold on. Okay. Okay, we'll talk about model-based decision making. We have learned about descriptive analytics and predictive analytics. So today we move into prescriptive analytics. So we are making decision using some analytical models. So it is based on descriptive and predictive analytics. So we use the information that we have gathered from the previous descriptive and predictive to make decisions. That we call this prescriptive analytics. So from the descriptive analytics and predictive analytics, we get prescriptive analytics. So one example of prescriptive analytics is profit maximization. You look into optimal spending on promotions, how do you price your products, and so on. So we need to develop some models for that. Okay, hold on. So prescriptive analytics models, examples. Inform is Institute for Operational Research and Management Science. The publications has included some real world cases. You can refer to the book. So modeling is a key element for prescriptive analytics. One of it is mathematical model. And then, for example, turbo router, they give an example in the book on decision support system for ship routing. Yeah. And then how do you make your what is the major modeling issues? First, you need to identify your problem. So actually, the most difficult part in making decision is identifying the problem. Remember, we learned, your class did not cover the topic of MIS. In making decisions, you need to identify the problem first. After identify the problem, and then you look into alternative solutions. From the alternative solution, and then you look into payoff for every solution. And then from the alternative solution, then you will choose. Yeah, so that is the process of making decision. So the first thing when you want to make to understand, to make a solution, to solve a problem is to identify what is the problem. Sometimes you find what we call issues or symptoms. Sometimes you find symptoms, but symptoms are not problems. Symptoms are things that crop up that you are able to identify easily. You could see, you could things that you can see in your record, in your business performance, drop in your profit, for example. So those could be not the main problem, but are just issues or symptoms. So you need to see what is the problem. Yeah, so you need to identify the problem. Example, I think I can put an analogy. For example, like when you have dengue, for example, when you have dengue fever in Malaysia, we have dengue fever. When we have dengue fever, the problem is dengue, but we can see symptoms like you have rashes, you have high temperature, you have headaches, stomach aches, and so on. Drop of platelet levels and so on. But those are symptoms. What you need to cure is the problem. So you need to identify from the symptoms, you need to identify the problem. Yeah. So from problem, and then you look into environmental analysis, you collect information on the environment so that you are able to identify the problem. And then from the problem, you could see what are the variables. We go back to what we have learned before. What are variables? Variables are things that interest us. Yeah, variables are things that interest us. Variables have fluctuations. We call them observations. Yeah. So things that interest us, for example, like profit and loss could be a variable. Number of sales could be a variable. Amount of sales could be a variable. Complaints could be a variables. So things that interest us are called variables. Yeah, so it is related to the problem. So you need to from the variables, you can see fluctuations of the variables, which we call them observations. So we measure variables, so you can see, we measure the observations, so we can see the dynamics of the variables. Yeah, so how do we can identify the variables looking into influence diagram, cognitive maps, and so on. You can see the relationship between the variables and amongst the variables. So I'll go detail later what are you see the variables. And then from getting more information, you can lead to better forecasting, more information on the variables, meaning that you can see, okay, this happened, this will happen, or there is a relationship between this variable to another variable, so you can predict. So you can have several models to predict these variables. Then we call it multiple models. Yes? Each represent the different parts of the decision-making problem. So it can be a static model, which is fixed, or a dynamic model, which change over the time. Yeah, so there are several methods of how we can do modeling. One is you develop models. We call it model management, like data. Yeah, so we call it model-based management system. We develop models. The next is knowledge-based modeling. Knowledge-based modeling is we use expert system. So it is more qualitative rather than quantitative. Usually decision support system use quantitative, but model-based modeling can apply at times apply qualitative. Qualitative are measures like things that of quality, for example, like say colors, or the perishables, the lead time, certain quality, so qualities. And then you can develop knowledge-based model. KB is knowledge-based models. The current trends in modeling, you can have cloud-based modeling tools. They are in software, or transparent models, visual models, multidimensional models, or influence diagrams. Yeah? So these are modeling. And then some categories of models, for example, optimization of problem with alternatives. We have the target is to find best solution for a number of alternatives. We can have decision tables, decision trees. In our case, chapter 7 will show decision trees. In chapter 7, I'll give an example of decision tree in chapter 7. We can do optimization via algorithm. What is algorithm? Algorithm is the step-by-step, how do you do things? Yeah, step-by-step. We optimize by having an algorithm, so we can do step-by-step of improvement process. Yeah, algorithm means step-by-step. Yeah, it can be linear or mathematical programming model. Yeah, and then optimization via analytic formula. We have EOQ, for example. So you have a formula in economic ordering quantity or break even. Yeah, so there is an analytic formula. Or simulation. You can simulate things. Yeah, so you can say what if and analysis. For example, you can put in certain figures and then you simulate. So this is another model. Heuristic. Heuristic is another word for rule of thumbs. Rule of thumb, meaning that there are heuristic models. There are step-by-step models that if you want to find, if you want to measure profitability, for example, you need to calculate the revenue minus the cost. So this is of course, the mathematical formula, but heuristic model is something that you do step-by-step. Heuristic rule of thumb. Yeah. Okay. Predictive model, it is a forecasting model, yeah, Markov analysis, and other models. So some such as what if cases, yeah, financial modeling, fitting line. So these are models. So when we want to look into mathematical models for decision support, so there are several ways to look at. One is a non-quantitative model, which is the qualitative model. We look at qualities, and there are also quantitative model. Quantitative model look into variables. Like I mentioned, what are variables? Variables are things that we look at that interest us. And then there are changes, dynamics of the variables. Of course, there are variables which are fixed, and then there are dynamics of the variables, and then we can observe the variables. Yeah, so the goal is to look at the dependent variables. This is the thing that we want to measure. This is the output, the result variable. For example, your profit, your performance, your sales, for example. So you want to have a result variable, but these result variable are dependent on other variables. They are dependent on other variables. So they have decision variables. Decision variables are within control of the management. So management can increase their campaign, for example, increase their campaign, number of campaigns, increase of promotions. Yeah. So those are decision variables. Yeah, you can have decision variables. We can have a formula, for example, rural campaigns, urban campaigns, or you can look into some other variables, say discount, for example, you give discounts and so on. So those are decision variables that can be controlled by the management. Then you have other variables, we call it uncontrollable variables. For example, fluctuation of exchange rate. The management doesn't have control on the fluctuation of exchange rate. Maybe the inflation, for example, yeah, increase of prices. So it is the management, of course, it's actually a national issue, but at the company level, we could not control the inflation, we could not control exchange rate. So these are uncontrollable variables. So we can see when we have decision variables, we include uncontrollable variables. We will develop a formula. Where is the formula? We can have a formula. Yeah. And then this formula is called mathematical relationship. The result of this formula, we will get, say, this is X, yeah, X. And then the result of this formula, we will get Y, which is the result variable. Yeah. So result variable is the dependent variables, but in between the independent variables and the dependent variables, there is another variables, we call it intermediate variables. Intermediate variables is, for example, there is another variables that add in. It could be, it is in between. It can be related to the uncontrolled variable, or it can be related to a decision variable. So there is another variable in between. So if A plus B, and then there is a between, there is a formula in between, then only it becomes the result variable in between, and intermediate variables. Yeah. So it can be, yeah, mediating variables, moderating variables, yeah, or intervening variables. Yeah. So these are models, yeah, that you need to look at when you develop models. So examples of these component model, for example, like inflation variable, we look into, for example, in the area of financial investment, the decision variable is the how much you need to invest and what are the investment alternatives you can put into a certain fixed deposit or invest into certain stock market or certain securities or certain bonds. So that is your decision variables, the end goal. So how do you measure the decision? What do you make? How do you make your choice? It's based on total profit or loss, or total profit or risk, return on investment, earnings per share, PE, price earnings per share, liquidity level. So the uncontrollable variables that you need to there are is inflation rate, prime rate, competition. Yeah. For example, you want to go in, you want to aim for example, okay, I'll just put an example here. I'll work out an example in a whiteboard. Yeah. For example, in decision we should on investment area, financial investment area. Yeah, financial investment. Okay, your goal, your decision variable is to obtain total profit. What will be your total profit? Okay, your decision variable will be how much the alternative investment that you want to make. And then the amount, how much do you want to invest in certain particular investment, yeah, amount of each investment. For example, they may put into certain stock market, certain shares, mutual fund, or you want to put into security bonds or FD, whatever. So this is the alternative. This is your decision variables, meaning that this is in your control. This is in your control. This is the ultimate result, your dependent variable, the ultimate result. But there is factors that you don't control here. Yeah, there are factors that you don't control here. Yeah, so for example, given here is inflation rate, prime rate, yeah, inflation rate, competition, yeah, okay. Say inflation rate here. Or exchange rate, or interest, for example. You don't control the interest. Or inflation. You don't control the inflation. The interest is set up by the bank. Or, for example, in Malaysia, we have the issue of OPR, which is the overnight rate. Yeah. Okay, and then
sorry, Prof. What about the market sentiment?
Yes, market sentiment. Yeah, market sentiment here. Market sentiment, is it controllable or uncontrollable?
Uncontrollable.
Yeah, uncontrollable. You cannot control market sentiment. Yeah. Market sentiment. Then people trust the market or not. Yes. So, and then eventually it will lead to, there will be an effect from, there will be an impact here, market sentiment, your uncontrolled, and then you will get your total profit here. And then of course, there are mediating variables in between. For example, like before you get the profit, there will be a cost, there will be revenue, there will be cost, and so on in between here. Yeah, so maybe there is other components, a tax, for example. Yeah, so there might be a variable here. So after you minus tax and so on. So this is between the independent variables, IV, your result variable or dependent variable, and then this is also an independent variable, but this is uncontrollable. Uncontrollable, ABLE variable. So this is, so we need, so you need to develop a formula, and then you see there are changes that you can control, and then there are changes that you cannot control. Then you can make some recommendation, decision, what you need to do. Yeah. Okay.
Sorry, Prof. But
Yes.
how do you model that?
In mathematical formula.
Oh, I see.
In a mathematical formula. Yes.
So you cannot enter the information in a software, and the software can provide you information. It's not such a thing. You need to come up with an equation or a model.
You come up with an equation. Yeah, we can need to come up with an equation. For example, advertising budget. For example, we know that our goal is the result variable is to achieve certain market share. And then we have in advertising budget. So where do we get this formula? Did we get this formula from the predictive analytics that we did? data mining, so we can see the trend, we can draw the graph. Previously, we learned about data mining, right? Data mining, we can see the graph. If there is increase on this, say advertising budget, what will be the amount of sales, and then the amount of sales, what will be the size of the market size. From the size of the market size, you can, how do you determine your market share? Is the total size of market, and then your size compared to the total size of the market, that is your market share percentage. Yeah. So your market share, there is a mediating variable, which is the size of the market. Yeah, and then size of your sales over the other over the total market size. And then there is a your decision variable will be how much you will spend, and then the uncontrollable variables will be the income, customer income, yeah, purchasing power, and so on. So we need to put in the formula. Where did we get the formula from? Our mining. Yeah, mining. We will have an example again later in chapter 7. Yeah. So does the manufacturing, yeah, how much total cost? The controllable variable would be the machine capacity, technology. You see that machine capacity, in reality, of course, when you buy the machine, there is a threshold level that they give you. Okay, you can produce certain output, a number of output at a certain period of time, an hour or a month, and so on. But when you actually run the production, machines have their defaults. Actually, they will put usually the average, the minimum, and the maximum. Even you drive a car, that is, they say, okay, you can go for 220 km/h, for example, but if you drive, actually you can be beyond that or lesser than that. So every machine have their own capacity, different. So, and then as time goes, there will be inefficiencies and so on. The machine capacity will reduce and reduce. Yeah. And then you look into the other controllable will be material prices. Material prices are dependent on exchange rate, dependent on logistics, and so on. Yeah, and then accounting, transportation, and so on. Yeah, so these are just examples. There are many more examples you can find there. So the structure of mathematical model, how do you this? Was your question just now? How do we get it? The quantitative model is developed by an algebraic expression. Yeah, so we have a profit, which is P is equal revenue minus cost. So we have simple present value formula. This is a simple present value. Present value formula is based on the cash flow and the interest rate. Yeah, so you have your future cash flow and the interest rate. So this is the formula. So what is the dependent variables? Yeah. For example, profit is the dependent variables, revenue is the independent variable, cost is the independent variable. But within the cost, there are components of controllable variables and uncontrollable variables, because there are things that, for example, like cost, for example, us in Malaysia, we buy things, for example, in US dollars. The cost we buy in US dollars, we know what is the cost, we know how what volume we want to order. But the exchange rate is things that we cannot control. We don't control the exchange rate. For example, cost, there will be a component of uncontrollable variable and a controllable variable. Revenue is something that we can push in, but the market, there could be some uncontrollable and controllable variables. So these are the profit. Profit is our determined variable. The formula is P is equal R minus C. This is the formula. And then if you can put in the revenue, and then you put in the factors that related to the revenue, put in the cost factor related to, we can somehow estimate what is the maximum profit we can get, what is the minimum profit we can get at certain market side, at certain condition. Same goes with the present value formulation. This is the present value is you calculating when you invest fund into a certain project or certain investment, yeah, or invest into a certain company, you buy anything. So the company will do continuously do operation, but in future, the income, there is inflation, meaning that there is a discounted, your cash flow is discounted based on the number, the amount of interest. Yeah, the amount of interest. We call it discounted cash flow. Yeah, DCF. I think those in accounting could remember, yeah, DCF. So when this is how you calculate your present value, is the future cash flow in number of years, and then divided by I, and then n is the number of years. Yeah. So this is the formula, but we can see the future cash flow is dependent on the future cash flow. We can control. We can forecast how much we can generate cash, but interest rate is things that we cannot control, and number of period or years that we want to invest in certain investment is something that we can control. Yeah. Okay, this is the formula. And then, okay, whenever you want to make decision, there are three situations. Whenever you want to make decisions, there are three situations. One is situation of certainty, where you have complete knowledge of the situation. You assume that you have complete knowledge. So all potential outcomes are known, and then you can yield optimal solution. But for me, based on experience, certainty is only a short, a short period of time. There is no certainty. You can say 10 or 20 years. You can see certainty between 3 to 5 years on certain situation. Things that you can control. Because like we mentioned just now, when we talk about dependent variables, these dependent variables comes on independent variables. The independent variables, there are things that we can control, that there are things that we cannot control. So when you talk about certainty, we're looking at things that you can control. So you can control certain things at a certain period of time. For example, materials are purchased within the same country, so there is no effect of currency, there is no effect of interest, you don't do so much borrowing and so on, less gearing. So you can assume you have complete knowledge of the variables, so all potential outcomes are known, so you can yield optimal solution. You make decision based on your knowledge. Okay, and then there is uncertainty, several outcomes, things that you don't know. You don't know. For example, like the weather, whether you can get supply of certain material at certain price, and then several outcomes. There are probability that you don't know. There are things that you are not certain. You don't know whether it will happen or not. So you can use Monte Carlo method or so on to calculate this probability of outcome. Yeah? And then the third one is risk analysis. There are probability that you are known. You can calculate the probability. So certain outcome, you can calculate what are the chances of this happening. So in 100 times, you do 70% every time. 70% will be successful, 30% will lose. It's not successful. So you know the chances are 70%. So you can calculate 70%. You can do risk analysis, probabilistic decision making. When the probability after several outcomes occurring, you can determine the probability of things happening. Yeah, so it moved from level of uncertainty to risk. Whereas at such uncertainty, you don't know anything at all. But after you do multiple times, I mean, you produce product and then you sell into the market. You can see in certain market there are trends, certain percentage of customers buying your product, and then another market, certain percentage of customers buying your product. So you move from level of uncertainty to an expected value. You move. So maybe in the initial venture startup, yeah, initial stage, you are at the stage of uncertainty, but over time, after you have sold the products or sell the product many times, you can see the trend. You can have some level of risk. Yeah, you can measure the probabilistic decision making. You can have probabilistic decision making. So zones of your decision making is moving when you increase knowledge about the variables. Yeah, increase knowledge about the variables. What are the dependent variables? Of course, you know the dependent variables. The dependent variables is your target. You need to identify what are the independent variables that affect the dependent variables. What are the contributory factors that would affect the dependent variables. After you identify them, and then you will look into the uncontrollable variables. And then the uncontrollable variables, after multiple times of occurring or occurrences, you can see the trend, you can see probabilities, chances of it, and then you will increase your knowledge. Yeah, so you move from uncertainty to risk to total certainty. But for me, based on my experience, certainty is only for a certain period of time, maybe 3 years, 1 year, 2 years, 3 years. Beyond that, there are trends that we cannot expect, and then they will be at the risk level. And then when your knowledge for certain situation become decreasing, you are moving from certainty to risk to uncertainty. Yeah, so you are less certain when there are situations that you start to lose. There are things that prop. For example, during this Ukrainian war, for example, things that you are not sure whether the supply, people in Europe not sure of the supply of coal or supply of fuel. So they are decreasing knowledge. So they move from certainty to risk and then to uncertainty. Yeah, so these are the zones for decision making. So you can use decision spreadsheet. Yeah, spreadsheet like earlier we have Lotus 1, 2, 3. Now we have Excel or any other spreadsheet. Yeah, to make decision models. So it is most popular end user modeling tools. So it's flexible, easy to use. There is an add-in function of analytics. So you can program it using macros, and then you can have what-if analysis. What-if analysis is when you change the variables. You change variables, or you can have goal seeking. Okay, what is the difference? Just ask you, just by looking at the word, what is the difference between what-if analysis and goal seeking? Just by guessing. Or Jefferson, what is?
I think if is very uncertain. Goal seeking is something that is really more achievable. Okay. What if is something that you really an estimate probably.
Okay, it's just like this. I just show. A plus B is equal to C. Yeah, this is how you can, this is just how do you understand it? So you can have two directions of this. Yeah, you have key here. Moving here is called what if. Okay, moving backward is called goal seeking. Moving backward is goal seeking. Yeah. So when you know your independent variables, I can make a sale of 1,000 unit. Okay, and then the variables will be it can be plus or multiply. And then each unit, 1,000 unit, each unit is about $100, for example. 1,000, you know, you can make $100,000. What if I increase my volume from 1,000 to 2,000? So when I increase by 2,000, yeah, so this doesn't count diminishing return. Yeah, okay. So if I increase 2,000 sales, each one is 100 ringgit, I will make to 100,000. That is called what if situation, what if analysis. You change the independent variables. What if analysis is changing the independent variables. Goal seeking for me, goal seeking is when your boss says, I do not know what you do, but I want to make your sale $1 million. So you have to achieve $1 million sale. So you play with the price and play with the volume. So the goal is being set to you. So you have your dependent variables given to you. Now you work backward to get the independent variables. So goal seeking, you start with independent variables. Independent variables. What if is independent variables? Start with independent variables. Goal seeking starts with dependent variables. Clear? Huh? Anybody not clear? I mean, so in exam, for example, in case exam, so we give you a goal, or you can say, well, maybe it's too easy if you give you a goal to tell them that it's good. So you need to understand somehow. You need to understand when you do what if situation, what if analysis. You will work from the independent variables to produce the dependent variables. When goal seeking, you work from the dependent variables, and then you determine what should be your independent variables. Yeah. So spreadsheet also have simple database management. Yeah. So with spreadsheet, you can easily do what if analysis and goal seeking. You can put the formula and then you can change the variables and you can see what is the independent variables or vice versa. It has a simple database management just by using boxes, cells. So it is a seamless integration of model data. You can do pivot and so on. It can incorporate static and dynamic models by putting in the formula in your boxes. So spreadsheet is easy. Example is Lotus 123 and Lotus Excel, Microsoft Excel and Lotus 123. Okay.
Sorry, Prof.
Yes.
Excuse me. Did I hear correctly? Prof said that this is going to be in the exam.
No.
Oh,
Just.
oh my God. Thank you, Prof.
I cannot tell you what will be in the exam. But if this is an exam, it's very easy, right?
Well,
depend on the situation. But it is easy to do. Actually, I've been, when you do projections, anybody have done projections before? Done projection. You are given task to do projection, and then you need to show your profitability, and then there is a target that the company provide you. We want to make at least a certain, say, threshold. So they give you a certain. So is that goal seeking or what if? What if analysis?
Goal seeking.
Goal
Goal
seeking.
seeking.
Goal seeking. Usually, what do you face? Usually, most of the time, the board will give you goal seeking task, meaning they will tell you, okay, I want to achieve this. How do you do that? But what if analysis is you play around in the market freely, and then you can estimate what will be we can predict. It's more predictive. You can predict. Okay. We move on. Yeah. Clear this first. Okay, this is simple loan calculation. Okay, so you can move backward or forward for example, loan amount, interest rate. I think everybody do this between what if analysis and goal seeking. So what if analysis is, for example, when you want to buy a car, you want to buy a house, for example, you put in the variables, for example, the amount of loan that you want to take, the amount of interest, the number of years, and then you can determine monthly loan payment. And then, but there are situations, for example, in Malaysia, we can only borrow loan up to our liability should be what do you call it? around 1/3 of our salary. So we can work backward. Monthly loan is 1/3 of our salary. We put 1/3 salary, and then we work backward, and then you can know this what is the interest rate, and we can expect and the number of years, and then the loan amount that we can where we are entitled to borrow. So that is between the what if analysis and the goal seeking. Yeah, everybody done this. Okay. Okay. So you can also use mathematical programming. Mathematical programming such as linear programming. Linear programming is the simple y is equal to mx plus c. I think we learned in our school. Y is equal mx plus c. This is linear programming. So we can draw the c is where it intersects at the y graph, y axis. Yeah, and then so it is designed to solve managerial problem based on certain scarce resources. We have allocate scarce resources. For example, how many number of fixed costs, for example. So that is the main, whether you incur or not incur any sale, there is a fixed cost. That is the C position. C position, meaning that that is line that intercept at your y-axis, right? Whether there is zero sale or any amount of sale, you will pass the amount of C. C is the point of C. C is at the y-axis. That is your fixed cost. And then for every unit, there is a variable cost. We call it contribution unit cost, yeah, or contribution margin. If you want to work out the profitability, it will be the margin, contribution margin. Yeah, so for every unit and so on, so you calculate the cost, and then you can see the graph of your cost, and then you measure against graph of your profit. You will be able to count your break-even point. Yeah, break-even point. So, for example, this is how you calculate cost. Total cost. Is equal to cost per unit times, yeah, the number of unit, of course, times by number of unit, and then plus your fixed cost. So this is how you get y is equal to mx plus c. This is y, your total cost. Cost per unit, your m, c, x is your unit. So when you change and increase or decrease the unit, you can see the total cost will goes up and down, but it will intersect at the y position total at the fixed cost amount. So you cannot go below the fixed cost amount. The fixed cost is your utility, the basic salaries, and so on. Yeah. So and then you can see how it intercepts with your revenue. Revenue will be what will be total revenue. Total revenue usually is at your selling price per unit, or we call it just price per unit, times the unit. Then it will intercept at zero. When you don't do any sale, it will not they will not make any revenue, so you will intercept at zero. Yeah, so fixed per unit. So you can draw this graph. Linear programming, we call it simultaneous equation, and then you can see where it intercepts. The point that intercepts is your break even. Exceeding that, you can see your company makes profit. Any question on this? This we learn in our secondary school. Right, Jefferson. We learn in school. Only that in school they don't tell us total cost per unit times by number of units, right? So This is mathematical programming. It's nothing new to us, actually, just putting it in the right perspective. So linear programming linear programming problem characteristic is limited quantity of economic resources. You can see the formula there, the total cost or total revenue, and then what will be your fixed cost, the number of unit maximum, yeah, limited quantity of economic resources. And then you look into resources, how it is used, and then solution, how to use the program, and then you look into how the activity and allocation is restricted by the constraint. This is you put them into a formula. So you need how to identify that. You identify first your decision variables. What is the decision variables? In terms of the costing just now, what is the decision variables? What is the decision? Decision variables are the decision are things that within your control. It is independent variables that you can control. Yeah. For example, what you can control? Can you control the unit cost? Maybe you can.
Possible? Yeah.
Yeah. You can control unit cost. You can control the volume. Yes. And then maybe you can control the variable fixed cost, or you can up and down fixed cost. Also, there are things that you cannot control in your fixed cost. For example, yeah, tariff, electricity tariff, they put a minimum amount for you. There is a minimum amount. For example, when you register electricity, whether you use or not use, there is a minimum amount. At least in Malaysia, they do have that. You don't use, still they have to pay minimum. So that is fixed cost. Yeah. And then your objective function is the formula y is equal mx plus c, or any formula. Yeah. And then the coefficient, we learned about coefficient last time, constraints. And then you can put, Lindo is a software for your information. Lindo is a software. In Lindo, you can put the mathematical formulation in the software, or you can just use Excel. You can use Excel and then you can run the model, you can have what if, or you can have goal seeking to forward or backward. So that is linear programming. Okay, this is an example given here. This is an example here for a company that they have two type of mainframe computers, CC7 and CC8, and then this number of labor days for CC7, 300 days to produce, yeah, labor in terms of days. CC8, 500 labors per days, and then so it is 200,000 per unit limit. Yeah, materials, and then how much it produce, what it will be the profit, and so on. So how many computers to build? So you have a formula. Decision variables is x1, which is unit of mainframe CC7, x2 units of CC8. The mathematical relationship is to maximize Z, which is the profit. The total profit is Z is equal to 8,000 x of x1 plus 12,000 of x2. You can given here 8,000 and 12,000. The profit from CC7 is 8,000. Profit from CC8 is 12,000. You want to measure how much will be the maximum profit, and then you see X. So how much do you need to produce X1, which is the CC7? How much do you need units you need to produce X2? So there is constraint, because constraint is uncontrollable. You can go a maximum of only 200,000 labor days per month. Yeah, 200,000 labor day, 200,000 labors per month. Yeah? So labor days meaning that labor time days. Labor days is labor time days. Yeah. So it can be lesser or maximum is 200,000. So you put this formula, yeah, uncontrollable formula. So you can get here, you replace the formula maximum, you can get x1 is must be more or equal to 100, x2 200. So this is the formula using Excel. I will go quickly because we're coming to 9. I need to move to the next topic after this. So you can just go through the example, and then this is another election resource allocation problem given Excel file. You can try. The formula is given here. Yeah. And then common optimization model is assignment when you assign things, yeah. Dynamic programming, goal programming, investment, linear and integer programming network models, non-linear programming, simple inventory model or economic order quantity. Economic order quantity, you can, I don't remember the formula, but there is a formula when it is a costing formula. Accounting, those who learn cost accounting, there is formula. And then they must count. And then they will have multiple goals, simple goal versus multiple goal. Yeah. So vast majority have multiple goals. And then there is, I want to move into utility theory. I think this one you can read. And sensitivity analysis, process of assessing the impact. Okay. And then, okay, we have mentioned what if analysis just now, and goal seeking. Goal seeking is backward. What if is moving forward. Goal seeking is backward. It's the same thing. Yeah. So one is the same thing, but working backward. You having X to find Y or having Y to find X. You just inverse the formula. We learn in our school mathematics. You just inverse the formula you can get. Yeah. From unit revenue to get the annual profit, or from the profit you go back to find what is the unit revenue and unit cost. This is what if analysis, goal seeking. Yeah. And then this decision tree. Okay. This is payoff. Payoff is how much it will pay to you. Yeah. It's based on payoff decision. What will be the alternative, and then what will be the return? The decision variables times the number of units, for example, and then how much or the dependent variables, the result that we will get. Yeah, dependent variables. Then I think you can. These are some tools. Okay, simulation is the appearance of reality. So instead of we simulate a certain situation, and then you can have, instead of just quantitative but also the qualitative aspect. Yeah, so it's more descriptive, so you can explain, simulate, imitate reality, capture the reality, or what if certain situation happen. Yeah, so it's more descriptive. Yeah, so advantages of situation. That simulation is theory is straightforward. There is time compression. Yeah. Okay. Disadvantage, it doesn't give optimal solution. Time demanding. Okay. How do you do simulation? I need to go this. How do you do simulation? When you do simulation, first you need to define the problem. Yeah. You need to understand your problem, and then you need to construct the model. How do you construct the model? Of course, you need to know what are the variables. We see what is the dependent variables, what will be the, what do you call it, result variable, what will be the independent variable, what are the things that you can control, what are the things that you couldn't control, and you construct the model. You need to test and validate the model. How do you test and validate the model? Because you have already done your data mining. You have data, you can test with the data. Earlier, we learned about, we discussed about how do you do testing of this model, and then you develop the design experiment, you conduct the experiment, you evaluate result, and then you implement the solution. With the implementation of the solution, you can have a report providing to the audience or the board what if situation, meaning that if you have done this, if you have, for example, in your projection, if the project is successful, how much you will be gaining every year, or how much you will be gaining every month, what will be your cost, what will be the labor costs, salaries that you need to occur, and so on. So you can show some reality, yeah, in the development. So you can use stochastic, which is probability sampling. And then for Monte Carlo simulation is for when there is no certainty, when it is uncertainty. Yeah. And then you can also do visual interactive simulation. Yeah? Okay, this is the simulation software. Some of the simulation software, you can just visit the site and try. Okay, we did not go into utility theory. Okay, utility theory will be covered in chapter 7. We'll move into chapter 7 after this. Okay, do you need I think, can we take a break for how many minutes? 10 minutes? 10 minutes sufficient? Yeah, we break at 10 minutes and we will start at 9:05. Yeah. Okay.
Okay, thank you, Prof.
Thanks.
Thank you, Prof.
Okay, we can. Any question before we continue? Any question on the previous topic? Okay, yeah, I think everybody can follow. Later on, actually, this class is recorded. You can still look back, yeah, on the on the records, on the recording. Okay, we move into the next topic, which is on the topic 7. Wait, I need to problem is. Okay, topic 7, we look into decision making again. So business analytics is about making decisions. So how do we make decision? We need to have an optimal strategy, to make decision based on the decision alternative, whether it is uncertain or risk, or when we have information or we have certainty. So we need to look into careful consideration of the risk. So risk analysis will provide probability information about the favorable as well as unfavorable outcome. So the outcome, sometimes we refer to as payoff. Payoff is actually how much do you gain from certain decision. We have alternative decision, like I mentioned to you. In order to make decision, we need to identify the problem. From the problem, we look into solution. We look into alternative solutions for the problem. From the alternative solution, for example, solution alternative A, alternative O, alternative 1, alternative 2, alternative 3, each alternative will have their payoff. If you have decided to implement alternative A, and then you will have the cost component, for example, cost component, or you have the pricing component and so on. At the end, what will be your payoff, which is your result variables, yeah, your dependent variable or result variable. So that is the payoff. So with decision analysis, you need to look into the outcome, yeah, the payoff that may occur, what will favorable or unfavorable outcome. So so you, based on the few decision alternative, always get a few decision alternative, and then you look into reasonably few possible future events. So this is the situation of future event. And then here we'll discuss about payoff table, decision tree, sensitivity analysis, and Bayes theorem. So how do you calculate for payoff for problem formulation? The first step when you went into analyzing your decision process is to develop problem formulation. You create a verbal statement of the problem. Actually, we call it problem statement. When you do research in the later semesters, when you do your business research method or your project paper, you will have to produce a statement of problem, your problem statement. So even in business analysis, you need to produce a verbal statement of the problem. Once understanding the problem, you can look into decision alternative. What are the decisions that you can opt? So if you do A, you do B, what are the alternative solution that you want to do? And then for uncertain future events, you have chance event, meaning that probability statistically, like I mentioned earlier and just now, we move from uncertain to certain risks based on the increment of knowledge or understanding of the situation, which come from the incidents, occurrences of these incidents that you start selling and you see certain market, you can estimate or can gauge certain amount of probability that if you sell this, the chances will be this and so on. So that is the chance events. So you will do outcome associated with each combination of decision, alternative, and chance event outcome. So you do that. This is an example here. This is, I obtained this example from the book by Cam, Business Analytics, Cam et al., Cam, Cochrane, Fry. Yeah, so this book by, so PDC, Pittsburgh Development Corporation, they commissioned preliminary architectural drawing for different projects. 3 projects. One is the first project is with 30 condominiums. Second project with 60 condominiums, and then the third project with 90 condominiums. So you need to determine which condominium which project they need to do. Yeah. So financial success of the project will depend on the size of the condominium complex and also the chance of the demand of the condominium. Maybe because 30 condominium, 60 condominium, and 90 condominiums have different pricing and so on. So, so the statement is to select the size. Yeah, you mentioned is to, you need to have a statement first. Yeah, put a statement. The statement is to select the size of the new luxury condominium project that will lead to the largest profit given the uncertainty concerning the demand for the condominium. So this is the first thing you need to do. Whenever you face a problem, you need to put a statement. How do you statement? What do you want to do? You want to select the size of the luxury condominium, whether it is 30, 60, or 90, that will lead to the largest profit. The largest profit. How do you get the largest profit? It will be revenue minus cost. Yeah. Given the uncertainty, there is issue of uncertainty. Yeah, concerning the demand of the condominium. So you need to look at the demand of the condominium. They will be given some uncertainty. In real life, actually, the uncertainty will come in from experience from the previous records. But in the exam, usually they will give you the figures for the uncertainty, the probability for certain uncertainty. So given statement the problem, it is clear that the decision is to select the best size for the condominium complex. So we have 3 decisions alternatives. Like I mentioned just now, you need to identify your problem, and then you look into the decision alternative. Decision 1 is to have a small complex with just 30 condominium. Decision 2, a medium complex with 60 condominium. Decision 3, a large complex with 90 condominium. So which one do you need to do? Yeah. So okay, in analyzing this decision, which decision you need to make, you look into the chance event. Chance event. Okay, chance event is probability. Yeah, it is mutually exclusive, so no more than one can occur. It cannot having all the 3, and then at least one must occur, meaning that they will build either any one of it, but they only will build one. So there will be only one only one possible state of nature. Yeah, so the 2 state of nature will be based on strong demand for the condominium and weak demand for the condominium. There is state of nature. So for example, small complex, the strong demand, they will have 8 demand. Okay, and then this is the payoff. The payoff is the amount that you can get. So this is given by $8 million. Yeah. For a small complex, when there is a strong demand, you will make $8 million. When there is a weak demand, you will make $7 million. Yeah. So this is state of nature. They have, after they calculated the formula, when there's strong demand, you can sell. They are, for small complex, there are 30. So when you can fill up maybe maximum 90% or certain percentage, not given in this case, but you can say whenever there is when there is strong demand, you will make 8 million. When weak demand, they will at least make 7 million. For medium complex, when there is strong demand, of course you have 60 condominiums. So when there is strong demand, they will make 14 million. Weak demand, we have 5 million because the cost for developing 60 condominium is higher. And then with the higher cost, the margin will be lesser. So make where the weak demand only 5 million. For large complex of 70 or 90 million, 90 condominiums, when strong demand, they will, of course, large complex will make, when there's strong demand, you will make large profit, 20 million. But when there is weak demand, you will lose 9 million because the cost of developing large complexes is more expensive. So you look into the payoff. Yes, this is the payoff table. Yeah, this is the payoff table. Payoff table, if you strong demand and weak demand and so on, so you look into the payoff table showing the combination of decision alternatives. Yeah. Okay. And then you look into, so okay, this is a formula to denote the payoff associated with decision alternative I and state of nature J. So you will look, yeah. And then you will calculate a decision. This is how do you calculate. Yeah? So for example, in when you have V3 is decision 3 is to have a large complex of 90 million, and then the one is the S1 is the strong demand 20. So you have SI, D3 and S1. So you have 3 and 1, you have 20. Yeah, so this is how you develop your payoff table. Yeah, just formula. And then you can make decision tree variables. Decision tree showing the graphical representation. This is decision tree. How do you make decision? Number one, you can use decision tree. Yeah, you can use decision tree. You put that based on the demand. So you have something like this. Small complex, medium complex, and large complex. The number one here in the square is the decision to be made. Decision to be made whether you want to build a small complex of 30 condominiums, medium complex of 60 condominiums, or large complex of 90 condominiums. And then from this, you can say when because status that if there is strong demand, you will make 8 million payoff. If there is a weak demand, you can get about 7 million payoff. You need to use this mouse, yeah? You can see the mouse. And then medium, 60 condominium, strong demand, 14, weak demand, 5, large, 90 condominium, when if there is a strong demand, 20, and weak demand, 9. So you can see what decision you need to make. So there is, this is what we call decision node. Yeah, 1, 2, 3. These are the chance nodes, the chances nodes. This is a decision node. Yeah, you need to make decision, and these are the chances nodes. Okay, I need to move this. Okay, the branch connects the nodes, leaving the decision nodes. Now, leaving the from the branch, the decision nodes, you have chance nodes. Yeah, and then you can see the payoff. Now we have without probability. When there is probability, you look into best case and worst case analysis. Just without probability, you don't have figures of probability. Say you don't have figures of probability. You look into the best case and then you look into worst case. So, and then so the best case for every situation. So we look into, so you look here, for example, here you can see the best case and the worst case. The best case, if there is a strong demand, you can make 20 million. But if there's lowest demand in you're doing large, you can have you can incur a loss of 9 million. Yeah, so this is how you can make decision. Or you can do medium. You can have at least you can have 5 million. Or if you weak demand, even at weak demand, you will still make 5 million. Can still make 5 million. But if you strong demand, you can make 40 million. You can use this for your decision making. Yeah, this is without probability. Yes, you look into worst case and then you look into best case. So Yeah. And then optimistic approach is evaluate each decision in terms of best payoff that can occur. So just now, 2015, that is the best payoff that can occur. And then for minimization problem, you look into the alternative, the smallest payoff. Of course, you don't want to pick up the 99 million loss payoff. The worst case scenario, you will choose medium, weak, or 5 million payoff at least. That is worst case. Depends on your optimistic approach. Yeah. So this is without the probability. So at optimistic approach, you will choose the largest one, maximum payoff, which is 20 million. Conservative approach, you will look into the worst possible payoff. Yeah, just now, minimizing your loss. So for small complex, maximum payoff is you develop small complex, and then you can see okay, just now we look at back. Minimizing you develop small complex 30 at the most weak scenario, weak demand, you still make 7 million. Did you get what I mean? Yeah. If you are very optimistic, you go for the large condo, 90, and then you can get 20 million. But if you look into the worst case scenario, you at the weakest level of the small complex, you will still get 7 million. You will still get 7 million. So what recommendation? So it depends on, okay, we are optimistic, we can make this. Or we can, because 5 is not good. You have worse, you can develop just 30 condominium, but you can still get 7. Or you want to develop 60 condominium, but you still get lower than the small complex. Yeah, you can get lower than the small complex, which is 5 million. Yeah. So this is without probability. This is best payoff, maximum payoff. Conservative approach, you look into the maximum of the minimum payoff. Maximum of the minimum payoff. Yeah, which is 7. Of course, you will not go for, yeah, for the minimum payoff, the maximum is 7. 7, 5, and minus 9. Yeah. Regret is the amount, the difference between, is actually opportunity loss. Yeah. Payoff associated with your decision and payoff that will be the most desirable payoff. For example, say at the given state of nature. For example, like, so for example here, whether your state of nature will be weak or strong. So what have you choose? And then again, the difference actually with your decision alternative against the best, that is your opportunity loss. Yeah. So this is how do you calculate, yeah, the regret approach. So the state of nature here, strong demand, 12, weak demand 0, yeah, 6, 2, and yes, so this is the formula that you pick up. Yeah. Okay, maximum regret. And then this is the approach. Okay, now we look into probabilities. The expected value is when you have probabilities. Expected value approach is you look into you identify the best decision alternative, and then you look into, you weight it, you do a weightage of payoff against the chances, state of nature. For example, here in the for S1 is a strong demand. Strong demand, the chances is 8/10. 0.8, 8/10, meaning that out of 10 units, of 10 occurrences, 8 will be in strong demand, 2 will be in weak demand. Yes, small. This is 8, 2, 8, 2, 8, 2. So the chances is there will be 8 of strong demand, weak is 2 demands. Okay, in this case study, is all are similar. 0.8, 0. So you in order to calculate the effective value, you will do a weightage. You multiply them. 0.8 times 8 plus 0.7 plus 7. Yeah, so this is the 8 is the payoff for strong demand for the small condo of 30 condo, small project. Yeah. So you multiply, you get 7.8, 12.2, 14.2. Yeah. So this is the expected value approach. Yes. You look into, you multiply the. So you can see the expected value for the decision 3 is highest, about 14.2. The chances of high demand will be 0.8. And then the chances of low demand is 0.2, although you have minus of 0.20 times 0.8, yeah, 16, minus of 2 times 9, still you still obtain, this is 18, minus 18, you can still get 14.2, still can get 14.2. The chances. This is how you recommend decisions. Risk analysis, you look into the decision alternative versus the payoff, yeah, and then you do risk profiling. So this is the risk profile. And then sensitivity and alternative analysis is determine how changes of probability will affect the decision, recommended decision alternatives. So this is the changes. Yeah, probability. So if there is any changes, this is 0.2, 0.5. So sensitivity analysis will measure the changes of this. Yeah, this is the example formula. Okay, expected value of sample information. Okay, I think you can just read this. Okay, this is the same thing. Okay, and then I want to move into, okay, this is expected value of sample information. So when you have sample information, you can use sample information to create the chances, calculate the chances. It's the same thing, but we use sample information. Yeah. So yet to be determined. Yeah. So it's sample information. Okay, and then I want to move into this is the same thing. Expected value of this is perfect information. When you have perfect information, yeah, with perfect information. You have perfect information. And then this is Bayes' theorem. What is Bayes' theorem? Anybody? Anybody still remember Bayes' theorem? Bayes' theorem is conditional probability, meaning that a probability things to occur after certain condition have occurred. And then there is 2 layers approach, meaning that there is posterior problem, meaning that conditional probability, meaning that let's show the formula. One incident have happened after the other incidents, meaning that incident A has happened. What is the probability of incident A happen? Yeah, so whether so in this case, okay, let's see for this PDC. Yeah, so we look into this F. F will be the favorable situation, yeah, favorable situation, favorable market report. When there is favorable market report, what will be the strong demand or weak demand after favorable weak report? What is the chances of favorable market report? Yes, so there is favorable market report and unfavorable market report, and then strong demand and weak demand. So what is the chances? Okay, there is a formula here. So favorable, unfavorable, and favorable. So the situation of the occurrence or the probability of A if B has happened. Yeah, so this is the formula Bayes theorem. Okay, think they just use this formula. This is a conditional problem, meaning that conditional probability. So you certain situation has happened, and then what is the chances of this situation happen? For example, favorable, and then this is the 0.9, a strong demand, and unfavorable, but a strong demand. Yeah. Okay, and then the last one is on utility theory. Okay, so far any problem, any question? No, you just continue with utility theory. Okay, utility theory is about at times we are not concerned on just the monetary value. At times when we make decisions, we don't just look at monetary value. We also look at other values. So monetary values does not necessarily lead to the most preferred decision. Yeah, sometimes we look at other things. So yeah, so when we talk about monetary, sometimes we look into the environmental effect. What else? The satisfaction, job satisfaction. Some people stay in certain job because there is satisfaction of job. Maybe closer at home, for example. You pay higher, but you have to be far from your family, for example. Yeah, so this is what we call utility theory. Utility theory looks at not looking at utility, the value, but look into other aspects as well, yeah, to measure the decision alternatives. So we put value to the other alternative. We put value of the other alternative. Yeah. So decision alternative, for example, make investment A, make investment B, or do not invest. So real estate price go up. Yeah. Real estate price remain stable or just go down. And then we look into the other alternatives. Yeah. So if, whether you want the formula. Yeah. So okay, utility decision variable. What happened is this. Okay. So you develop a table using a payoff table, using monetary value, and then you identify the best payoff, which is for each utility. For example, worst payoff. Okay, you look into each utility. You convert each monetary value to a utility. Yeah. So you don't just confine into you put the value, monetary value, you put into utility. So this is utility. For example, you make 50,000, utility is 10, 30,000, 9.5. You convert monetary value with utility, and then you also convert the other components, which is non-monetary value, to utility. And then you measure the utility, and then the thing is similar with how you do it is similar like what I explained just now. Only thing that you don't measure the payoff based on monetary value. You give a utility value. And then this utility value, you can include other utility, meaning that satisfaction, can other utility. Yeah. So it's not really shown here. Yeah. So, but this is what it means. Actually, you add in other utility value. Yeah. So you can, yeah. So this is add in other utility value instead of just, and then even the monetary value you convert into utility value. You don't calculate based on the amount of monetary value. You convert them into a monetary utility. You give them a utility value. Yeah, and then okay. This is exponential utility value. Yeah. Okay, I'm quite fast because chapter 5, chapter 7 is quite short. Okay, any question on chapter 7?
Prof, so
Yes.
on this one, this Bayes theorem.
Hmm.
So while I get the idea of the Bayes theorem in of itself, But for this particular problem, how did you translate the probability within the favorable and unfavorable?
Okay, this one, the
Mhm.
Bayes theorem. Yeah.
Mhm.
Okay, the probability is actually given here, 0.9%. Okay.
Okay, so this is the one where
Yes.
this probability is from prior experience.
Yes. It's from the prior experience is given.
Okay.
So it's a conditional. The probability is given.
All right. All right.
It's actually by
Clear.
chances. How do you calculate probability? It's actually by chances, meaning that actually, and then when you calculate Bayes, it's based on the probability given probability. So how do you do probability? Is by the occurrence. Yeah, the occurrence. The word is occurrence. OCCRRENC, yeah, occurrence. Yeah. So how many it happens? Meaning chances. Like we throw dice or we throw coins, right? So how many times it occur? So then the probability is calculated there, and then Bayes theorem gives you the formula. What is the chances of AI happening if B has opened and B has happened? Conditional. AI happening if B has happened. So we put the formula of the formula is here. The probability of A happen, probability of B happen, and A happen. This is inverse of this actually. Yeah. So
does that mean in this particular case for the market research, that means person A, how they rate that occurrences will be different than person B?
the person A, correct. Okay, it will be similar because how do you calculate the chances? Is actually from the previous record of the company. Every time when there is a favorable news, a certain percentage of people will buy. When there is an unfavorable news, a certain percentage will be. So that is from historical record. So everybody will have the same calculation. Only that, then so when when it is favorable, what will be the chances of a strong demand, and then if it is unfavorable, what will be the chances of weak demand, for example, like this. Yeah, so those are, so that is from the previous historical record. Chances comes from historical record. Of course, we calculate the probability, but the chances is, this is a formula given, but this is by Bayes. I don't have the detail, but if in other recordings, there is an explanation how Bayes come up with this theory. So it is a theorem that he calculated, but the amount of chances, the figure for the chances is based on historical record. It's based on historical. So everybody will have the same in the company or in the same situation. Okay, any question so far? Today we learned a lot of mathematics, statistics. Many statistics. This is actually things of actually revision. Revision. Some things I also do not recall, but these are the things that we have learned in our school. Yeah, I think all except for utility theory. Utility theory is something different. Utility theory is you exclude monetary value, because previously we talk about payoff. Utility theory, okay, but how you calculate is based on you. How do you determine the number of payoff that you want to calculate? Yeah, base payoff. This is how do you calculate the utility of payoff? Yeah, best payoff. But the expected utility, this is the formula. How do you calculate the expected utility? But the concept is you don't calculate based on the monetary value. You give a number for the utility, expected utility. Meaning that you need to understand this, meaning that sometimes say anything that exceed 50,000, you give 10. Anything exceed 50,000, you get 10, for example. So whatever amount is, it's not based on the value. It is based on the satisfaction. Utility is the satisfaction that you gain. So that you can compare with other utilities. So for example, when we deal in the actual business, we need to deal with, for example, we talk about SDG. Anybody recall what is SDG?
Sustainability.
Sustainable development
development
growth.
goals,
Yeah. And then when we talk about sustainable development growth, we don't just look at monetary. We do look at environment. We look at human relationship. We look at other aspects. Yeah, there are components of alleviating poverty, something like that. So we look at all components. Yeah. So we also give, besides monetary, we also give utility value for this component. And then we measure them. So when we calculate them, we take into account same formula, the expected utility just now, you multiply by the expected utility and the amount, and then you get the figure. So same thing. Same formula, only thing that we don't calculate payoff based on monetary value. So, but it will be based on your situation by situation. Meaning that some people prefer look at environment, some people look at certain thing, scientific value and so on. Okay, and the rest is, I think, things that we have learned in our, most of it are the things that we have learned in school. Only thing, for example, like we have learned just now, when we talk about the linear programming, we just put in formula. We just put in formula on, for example, revenue, total cost, formula, mathematical model that derive from business relationship, business components, business variables. Yeah, today we talk about variables, a lot of variables. Yeah. And then you need to understand what is independent variables, what is dependent variables. Independent variables, there are things that you can control, there are things that you can, this is a decision variable. Decision variables, which you can decide, but uncontrollable variables that you cannot decide. And then we have mediating variables, which is in the middle. And then we have resulting variables, which is also known as your dependent variables. Okay, that is the thing. And then the relationship from between the independent variable and so on up to the resulting variables are algebraic formula. How do you get this algebraic formula? Based on the, for example, economic order quantity, the present value, or discounted cash flow, profit, and so on. Yeah, so these are the formula that you put in. Yeah, so mathematical arithmetic, or we call algebraic. Okay, any questions so far? We have done quite fast. The topics. Next week we will cover, what we will cover next week? Let's see. Next week. Let's see. Oh, we don't have class next week. Do we have class next week? We don't have class next week, right? Do you have class next week? Next week?
No problem.
No, yeah.
No, Prof, we don't have.
We don't have. So, okay. Any questions so far? I don't. Okay, we'll see. But next week you will be covering. No, the other class. You'll be covering. Let's see. On. Oh, that big data. Or simulation. We'll go detail on simulation. Yeah.
Sorry, Prof.
Yes.
Yes, couple of questions here.
Okay.
I just would like to imagine or model in my brain how a question for the final test will be. I just want to do a little modeling. How can it be? How is going to be written, the question? But I cannot figure it out. Just give us a little bit of idea.
If
How
there
the
is,
model
if there is a formula, let me see. Let me see. I don't know. I also don't remember what is the let me see.
Will it be more like a case for us to write, or it will be literally questions for us to do modeling?
Okay, on your case, on your exam, okay, I'll just give you some. It is not exam actually. So this round you will not having exam. You will be having what do you call it? Assessment.
Okay.
You will be having take home assessment.
Yes.
Take home assessment meaning it will be much easier for you. Not that much easier, but you can read, meaning that you can. So there will be not much formula. There will be not much formula that you remember, but you just need to understand the concept. You just need to remember the concept. Not familiar, but the concept. Meaning you need to know the concept. Meaning that from descriptive analytics, what do you get from descriptive analytics? And then from descriptive analytics, how do you bring it for predictive analytics? And then from having figures from the predictive analytics, how do you make decision? The case, it is a case study. So the question will involve an industry. So an actual situation of an industry at the industry level. And then you need to make some recommendation or proposal. But in order to make that decision, to make recommendation or proposal, you need to understand how do you bring the data that you get from the mass, and then how can it be applied to make decision. For example, what we learned today is you can use formula, and then but it is a take-home assessment, meaning that you will be given a number of days to look at to obtain the formula and so on. So, but the question is not about the formula. The question is about whether you understand how do you bring up the data so that it can help you to make decision. Because data is available everywhere. But how do you make decision using that data? Business analytics is about decision making. Decision making using data. Data is everywhere. So how do you make decision based on the data that you have surrounding you? For example, like today we talk about chances. Chances are occurrences. So how many times have people calculate? How do you calculate chances? It's easy actually. You can say chances of making profit or chances of making loss. You look into companies, okay, this company making loss, this company making profit, how many percentage of the total, and from the total, how many percent making loss? 70%, 30%. Okay, that is chances. And then from knowing the chances, you can see when there is another variables. For example, we learned today, weak demand or high demand. Yeah, strong demand or weak demand. If there is a strong demand, what will be the chances? With the weak demand, what will be the chances? And then you can, so then you can apply Bayes' theorem, for example, when there is unfavorable condition. So what, and you have strong demand, what would be the chances? And then from these chances, you can calculate the expected value, EV. How do you calculate the expected value? You calculate payoff, multiply the chances. Yeah, the payoff, multiply the chances, you can get your expected value. And then you compare the expected value. And then, for example, you have certain situation, you can say, okay, strong, what your management say, the board of director don't want to lose. What is the worst case scenario? So you look into, for example, case given today, you have a smallest condominium, but it can have larger return compared to the medium-sized condominium. So how do you calculate it? And then you are going for a proposal, for example, in a government department for government project. Government is not just concerned about monetary. Government asks you, how do you conserve the environment? How do you conserve the environment? You need to put that into your calculation as well. You use utility theory, meaning you instead of putting monetary value, you put the utility value. You can include environmental factor. So, and then you make decision.
Wow, Prof. Prof, respectfully, may I recommend if we can have a dummy exercise before the test, because I can see, Prof, is a little bit, it's kind of like, in my humble knowledge, probably my other classmates, they are pretty good, but you know, when I can see that you give it the final exam like that, no matter if you give it 3 days to get home, you know, if I can bring it home, I might not be able to. But if we can have a dummy, let's say we can have a couple of examples that we can do together, and we can try and see.
Yes. Okay, we will do.
I mean?
Okay, we will
Like
do,
a
because
little...
I'm pushing two class. You can notice that we have 10 total, but I'm pushing two. For example, today we have two because at the last day we will have a presentation. You will do your presentation. There will be 2 portions on the last day. Your last class, I don't remember the date. During your last class, we will start with the presentation. After presentation, we will have a revision. During the last class, we have a revision where we will revise everything, and then we will do some. Now that you have asked, you have requested, I think we can do some short exercise.
Correct.
Yeah,
Like a dummy test, something like along the line, so then we can be prepared.
I can give you. What we can do, we can break you into groups instead of, because in exam, in your assessment, you'll be doing alone. We will break you into groups. After your presentation, I'll break you into groups. We will give you a short case study, and then you work on that case study, and then you come back, and then you present your recommendation, what decision to be made.
Can we do the case study together with Prof instead of we doing in the group?
Can. Usually, I will ask you to do first, and then you come back and present, and then we will. Is it okay with you, Safi?
No, we want to do together, then only we do ourselves.
Okay. Okay. I will break you into group, and then I will move from one room, one room to another room. Yeah, because I cannot attend to all of you at one shot. So I'll break you into smaller group, and I will move from one. I will guide you from one group to another group. Okay.
Thank you so much, Prof. Thank you so much, Prof.
Okay. Any other question? We are early by 10 minutes. Yeah. Jefferson, Safi, okay, Safi? Can you follow today?
Okay, it's just that I haven't installed the software, the R software.
Yes. I need to groom you how to use, but because today's topic, it is just Excel. This topic is just Excel. Yeah. Okay. Because but of course you can also use R, but it will be too complicated. And then, did you find anybody have started doing the question on the guidebook?
Which question, Prof?
At the back of the guidebook, in the LMS, there is a guidebook. At the back of each topic, there are questions.
The one that I've attempted was actually there were 4 data sets. The 4 data sets that you passed. But there is one question that is not that actually the questions only address 3 of the data sets, which is the athletic, which we touched the last class, athletic.
That in the LMS there are other data sets given.
Okay. Yeah,
Never
and
check.
then there's the growth, the birth life. So that
Yes.
one done already, but the growth value. So there's no question
Gro-
to that one.
Okay, there is no question about the gross value. Actually,
Yeah.
there's another question. I didn't give you the question. Okay.
Yeah.
Okay. And everybody have tested. Safi, have you tried the question, Safi?
No, which Jefferson, where to get the
In, in,
question?
in the guidebook,
Yeah, the cost outline.
in the course outline, the guidebook,
Of
there is a
course, outline.
guidebook
Okay, okay, okay.
in the guidebook. Yeah. So you try the question, because at the end of the class, I'll give you the answers, but I cannot give you the answers now. I'll give you the answers later. At least you tried first. If I give you the answer, then you don't try. Okay, actually, I prepared the answers. I prepared the answers. When I send it to the admin, I see that the answers is not put there. And then it's okay. So I will give you the answers later. Okay, well, please try. And then there are also questions in, okay, but you because you are using the textbook by Ramesh Sharda, right? Yes, there is another textbook that I use, but it's not there. Okay, any other question? We have 5 more minutes.
Yeah, Prof. For
Yes.
the group
Assignment.
assignment, the Edina Clinic, that one we still don't know when is the
The due
due
date
date.
is 1 week before your presentation. At least 1
Wow.
week. So I need to go through your
Okay.
paper before you present. Okay, Edina
1 week.
Clinic, you need, I don't recall whether you need to form groups. Yeah, you need to form groups, but it is best that you break up your groups into 2. You break up your groups into 2 because you need to develop 2 dashboards. One dashboard is for the clinic manager. The clinic manager look into staffing, look into beds. Yeah, so the clinic manager, what are the concerns of the clinic manager? Is staffing, beds, and then there are KPIs that they need to monitor for the clinic managers. The other KPI, the other dashboard is for the COO. COO will look into operations, will look into profitability, and so on. And so you can also do same thing, do both, or it is more organized if you break up your team into 2. So, or sub team, subgroup. One group do the clinic manager, the other group do the because I was advising the physical class as well. Whereas I'm teaching business analytics, the physical class. And the physical class come in together and then ask a lot of questions. And then I recommend them to break up into 2 so that one group can concentrate on clinic managers, one group is clinic. Because anyway, it is looking at different perspective, but you can later on share your idea with among your group. Anyway, you will be presenting them. Okay. I hope there is no issues, no problem in doing your group assignment on the dashboard. Okay, you can use any tools to do the dashboard. Okay, any other question? Ivan, Azani, Safi, okay. Faizatul, Pawas, any question?
Prof, excuse me.
Yes.
So, Prof, I'm looking at the LMS group assignment. So you
Yes.
mentioned Edina Clinic is an internal medicine clinic within Fairview. So
Yes.
an integrated health system. This is what we are talking about, am I right?
Yes.
And we need to write a paper. We need to write. But Prof said that we need to do dashboard.
Yes.
I thought we need to write a normal assignment. Like
no, they develop a dashboard. Develop a dashboard. The dashboard you can use Excel. I think I'll put up some link. I will put up some link. How do you do your dashboard using Excel? Simple. It's not really complicated. It's simple. As long as you have identified, you can just use Excel. It is a hands-on. Okay. And then it's best that it's easy. It will be easier, not best. It will be easier for you if you break up your team, your group into two. So each do one dashboard. Each group do one dashboard. Yes, Jefferson. Okay, Jefferson. Okay, Jaime.
Yes, Prof. If you send us the link, that would be fantastic, Prof.
Yes,
so
I will
much.
send you the link. I will send you the link in your WhatsApp because I've sent the link to the other class. I got confused sometimes.
All right. We can
Okay.
separate in groups and we can start working on this.
Okay.
Thank you, Prof.
Okay. Okay. Any other question? Otherwise, we can adjourn for today. 9:59. Yes, Safi.
No, thank you, Prof. Good night.
Good night. Thank you. Okay. Okay. Thank you very much, and see you again next class.
Thank you, Prof. Good
Thank
night.
you.
Prof, I
Bye.
appreciate it. Thank you so much, Prof.
Thank you,
Thank you.
Prof.
Thanks,
Good night.
Prof.